Tēnā koutou katoa. Welcome to the last of our mammal pest talks for Biosecurity Bonanza 2024. It's my privilege today to introduce Dr. Andrew Gormley from the Wildlife Ecology and Management team and Maddie Eckrich from the Digital Solutions team, both at Manaaki Whenua. Andrew has a background in quantitative ecology and has an interest in developing decision support tools to provide insights and guidance in wildlife management. Maddie has a background in software development and wants to build software that can help protect Aotearoa New Zealand's biodiversity. Today's talk is on the development of TrapSim Plus, an online decision support tool aimed at helping land managers develop plans for controlling invasive mammals. As with our previous sessions, a question and answer session will follow this talk, so please submit your questions in the chat during the presentation. We will try and get through them all, but if not, the team will respond to any questions we don't get to. I'll now hand over to Andrew and Maddie to share their presentation, TrapSim Plus, a simple to use planning tool for control of invasive mammals.
Cool, thank you, Sam. Kia ora, everybody. And yeah, thanks for tuning in on behalf of myself and Maddie. This is a joint sort of a project between our two teams at Manaaki Whenua Landcare Research. And yeah, sort of presenting our development of this online planning tool to help guide predator management. So I guess what's it all about? So pest management in New Zealand, as most of you would know, if you just flick to the next slide, we kind of focus on predominantly on the big three, as they're sometimes called, which is more than 3 species. We've got brush-tailed possums, Norway shiprats, stoats, ferrets, and weasels. A lot of these sort of fall under the predator-free 2050 aspirational goal of eradicating all these species, but a lot of work goes on outside of that program on these species as well as others: goats, hedgehogs, mice, feral cats, dock. There's regional councils, community groups, sanctuaries. There's lots of collective efforts going on around pest management in New Zealand. So it immediately brings up some big questions about, how do you know when you're conducting landscape scale control, whether that's at a catchment or sanctuary or a park or a community-led project. There's lots of questions around when you're doing ground control about the types of devices you use, how many do you have to put out there, how long do you have to set them for, and how often do you need to check them? And these aren't trivial questions, and the answer to that depends on a lot of factors. Slide. There's heaps of information that would determine what an appropriate level of trapping would be, what a strategy to achieve your goals. And some of these are animal specific, species specific, so animal home range size. So species with small home ranges, all things being equal, would need closer traps to be set sort of close together to be able to expose potentially every individual to a trap. Trap interaction rates, so some devices will have more attractive to animals than others and have a higher success rate. And there's a lot of other factors that go into that. But that still doesn't answer the question about what you actually need to do. So we've got, we can, as a quantitative ecologist, based off ecological field sort of research, we know a lot about animal home range, we know a lot about interaction rates between traps, and we can build computer simulation models that can sort of help us explore these options. So some of this early work was motivated by a project that Bruce Warburton and I had with Hawke's Bay Regional Council, and it was looking at a kill trap network that they had and how they might refine it to save money but also maintain the efficacy that they currently had. And that involves removing traps, looking at the checking interval rate, but it's really expensive and hard to do that in compare lots of scenarios out in the field, so we can have a computer simulation model that can help explore that. And that work, but not everyone wants to download and learn how to code and do software. And so we were sort of, from this work, we took that to the next stage and said, well, for a land manager, how can you take this modeling and apply it yourself? So We took the R model and deployed it using a package called Shiny, which allows us to develop a user interface and deploy that online on the web, freely available to use. And making this decision support tool for land managers that can help provide some level of guidance so they can say, well, are we even in the right ballpark with our trap layout and strategic option for achieving the goals that we want? So TrapSim's been out for a wee while. That was 2017. We started that. It's a prototype. It's got limited functionality. There's no real guidance for users. It's a little bit non-stable. If you simulate an area that's got lots of animals and lots of traps, it can sometimes crash, and we don't have costs included in there. So the motivation for TrapSim Plus, which is what we're talking about today, was part of the strategic outcome 5, which for the National Science Challenge by Heritage, which was guiding best practice for predator freedom. And so it was to take this prototype and turn it into something a little bit more robust that can help guide users, include costs in there, and help guide the user through those decision processes so they can hopefully answer questions about what is likely to be achievable for a given level of funding, can enable simple comparison and ranking of results in terms of different scenarios that they might want to explore, and looking at things like the efficiency, so the balance of the cost of doing the control versus the number of animals that may remain. So we in the WEM team, the wildlife ecology team, I mean, we've got the skills to develop the initial prototype, but don't have the skills at all to develop to further that development of TrapSim to meet the goals of that National Science Challenge project. So we've engaged with Maddie and the digital solutions team to move TrapSim from what is kind of a bit of a sketch, so number 1 or 2 on that iterative Mona Lisa at the top there, and moving that towards a more complete product. So I'll hand over to Maddie now, who will describe that process, and then we'll give an example of it at the end. Thanks, Maddie.
Thank you, Andrew. Yes, so I think it's pretty easy if you're not in the software world to sort of think like, oh, I'll just give what I've already done to software developers and, you know, they'll just zhuzh it up a little bit and there's not a lot of work to do there. But there is quite a lot of work that can be done from, you know, what Andrew had already done, and we prove that by spending time working on this project. So what the most important thing for us, for our team, was collaborating with the strategic outcomes and the WEM teams, because we can't produce software without engaging regularly and consistently with our stakeholders. And we absolutely wouldn't have been able to do this without having Andrew there at every step of the way. So obviously we had to do a little bit of planning at the beginning, but we took this iterative approach using an agile development cycle, which is a very software development thing. Don't worry if you don't know what that is, but basically we tried our best to include core functions of the tool earlier on to sort of give a more filled in idea of what this tool would look like, so more like a 3 and a 4. And that's important because we can then go to our stakeholders and get that feedback consistently and frequently. If you do it in a more incremental way, you might find yourself with an incomplete Mona Lisa at the end. So that was quite important to us. So in order to make TrapSim Plus the best that it could be, we had to take what Andrew had already done and split that tool into 3 but connected components. So we already had the R model. We needed to create a new user interface that was a little bit more robust than the shiny one. And then we added a layer in between those two, which provided some security and allowed those two parts to talk to each other. My colleague Nicoletta reorganized and refined the R model to sort of compartmentalize a lot of the functions that were already there, and that allowed the model to be more robust, reusable, and much more testable. For the new user interface, we had to decouple the R model from the Shiny user interface. So if there's any scientists here who've ever used Shiny, it's pretty easy to have those two things very intertwined. So we had to start from scratch. We completely removed user interface stuff from R, and we built a new user interface using a popular TypeScript framework called Angular, which, if you don't know what that is, doesn't matter. You just need to know it was able to give us more control over how the tool behaved and looked. So both early on in Andrew's early requirements way back in the day, his requirements gathering way back in the day, and our requirements gathering, we learned that to open up the tool to a wider audience, we need to provide more information or default parameters up front. Some of the data required to make the simulations run are a bit technical, and it's also challenging because this sort of data, we can add defaults in, but the data is changing frequently as new research is coming out all the time. So it was important to us that we were able to give the WEM team the ability to configure those values quickly without having to incur a bunch of costs by asking us to update the code base again, make big changes, every few months. Yeah. So that was a big part of our design process. And that's going to be quite important because obviously as well, just noting that the new devices are coming out all the time and they're going through testing all the time. Their prices are going to be changing as well. So not just that, but also the data behind how they behave is going to change over time. We also wanted to make sure that a more advanced user with knowledge of those more technical parameter details would be able to tweak them themselves. So we had to make it configurable and also make it tweakable for users who knew what they were doing. So some examples of the kind of value that our software development team was able to bring to this project was that we were able to add a slightly more sophisticated mapping tool. Previously in the old prototype, for example, you could only upload a shape file to sort of select where you were going to do your trapping simulation. And so wider audience, not everyone's going to have shape files available to them. You might not even know what they are. That's okay, because we were able to add in the ability to draw that area on the map. We were also consistently asked, both Andrew and our team were asked to make the pest population estimates for the areas more realistic. So this was important because pretty much every user we talked to and the stakeholders were like, I don't know how many possums are in this area. I couldn't tell you, I know how many I might be trapping, but I don't know how many there are that I'm not trapping, So one of my team members named Thomas was able, he came up with the idea that we could pull through some habitat and vegetation information that we have at so that when you select an area, you have like an idea of, is it viable, the pest species I'm looking to capture are able to live in this area, sort of thing. We also focused on making the whole tool intuitive, user-friendly, and we were able to test this by inviting some predator-free Wellington volunteers to sort of walk through the tool, and they were able to give us feedback on what was working and what wasn't working for them. So a summary of some of the features that really differentiate TrapSim Plus from the original TrapSim is that it's suitable for 6 different species. I think it's possums, ship rats, Norway rats, weasels, stoats, and can't remember the last one. Ferrets. Thank you. Yeah, so and something else as well was that was really important early on was that wanted to know which devices were available for which species, because they don't always pass NAWAC testing for, say, like ship rats versus Norway rats. You might think you can use the same traps for those, but there are differences between them. So we really wanted to make sure that people had the correct information, or as correct information as we could provide going into it. We also included a sort of immigration or incursions into the area. That was some feedback that we were able to get. So those pesky stoats that keep getting in everywhere can sort of simulate that. And yeah, we were also able to add in the testing status for the devices, so whether or not they pass that sort of ethical testing. Yeah. Right. So users, when they use a tool, they add in their own parameters and they build up a list of scenarios and run the simulations. And the results of those simulations can be sorted or ranked by a few factors, including the cost of the length of time or the population change. And in the examples here, we ran two similar scenarios to control for stoats with a BT200 double set devices. And they both had a pretty similar result, but we've got this calculation called the efficiency index, which will tell you, like, it will help you compare like how efficient each sort of scenario is. So the second one has a higher efficiency index despite having this very similar outcome, primarily because it costs $1,000 less. And even though it ran twice as long, it ran for 2 months instead of 1. So that's a sort of one example, but we're going to move on to a demonstration of the tool in action. So bear with me as I switch screens. All right, Andrew, would you like to take over explaining how this works?
It's always a little bit risky to do a live live software, but kind of wanted to show just basically this is just a brief look to show how really easy this tool is to use. So as Maddie's shown there, sort of zooming in on an area, might be interested in, for those that know Banks Peninsula, an area around sort of Wainui area, and so you can just point and click and draw. If you don't have a shape file, you can draw your area, and you can draw it pretty rough, and then you can click on little nodes in between at the lines to make the shape fit where you want it to be. So that's the area, and as Maddie described before, it goes and looks at the land layers underneath and tells you a little bit about your habitat. And then based on that, you choose your pest species. So I think if we go with possums, and so there's an option there to look at your previous level of control, and all that really helps define is if you've had moderate control before or sustained control, that gives you a bit of a range about how many pests might be expected in there in your area. So you click on that one and it says it could be anywhere between 190 to 380. If you've got more local knowledge about that, though, you can adjust those boxes. There's some advanced parameters which relate to things like population growth rates and immigration rates and things, which you can alter and change, but generally they're sort of hidden away, but they can be tweaked. So then you set up your scenarios. So if you wanted to set the first one up, put a start and an end date for your length of control, choose your device. So we could say like an AT220, which is a self-resetting device. You can see there that it's passed an AWAC test for possums. We might say, well, we've put in, I don't know, a couple of 100 or 50. Yep, we'll go with 50.
50.
Go with 100. However many you choose.
Yeah.
There's options there about the device servicing interval. So for a self-resetting trap like that, maybe you only want to check it every 30 days, for example. There's an option around, well, an input about how many devices a person could service per day, what the labour cost would be, and that all gets put together to help calculate for that strategic option, that scenario. It's going to cost around, you know, $50,000 or so for that length of time. I mean, this is really ballpark. It's intended to give you approximate values. So obviously, when you're doing trapping, there's lots of other fixed and variable costs that would get included in, but it provides that sort of overview level. And then you might want to compare that to a second scenario. So choose the same sort of dates. We'll go with a Tim's trap. Hasn't passed NAWAC testing for possums. That may or may not be a consideration for you in your area. Look at a similar number of devices, and then maybe a like a 7-day interval for checking. So it's a cheaper device, but you might want to have to check it more frequently. And you can set up as many of these scenarios as you like. And when you're happy with the 2 or 10 or however many you want, save all those and then run it. And then a little Kiwi jumps along, it's running in the background, and then you get your results. So you can see here that they both achieved a relatively similar, for this area, decline, like 90-odd% decline in population over time. One was more expensive, and the cheaper one has a higher efficiency rate because it achieved that same level of reduction for a cheaper cost. If your aim is some low-level suppression, then you might take these results and go, well, actually, that's the appropriate level of trapping we need to carry out. If your aim is eradication, they're not getting there, so it tells you something about that you need to really sort of up the effort to achieve that goal. And if you don't have the budget to do that, then that's information in itself. So you're not sort of just doing continual trapping, hoping to eradicate, but only getting that low-level suppression. It's not an optimization tool. The aim is it's to help to guide a manager in that process. And so you can, if you're not happy with those scenarios, you can go back and you can tweak them and change them and try out new ones. And that's the aim of the tool. Yeah, awesome. So as you can hopefully see, it's pretty easy to use and pretty quick. But lots of simplifications. You know, it reflects reality to some degree, but it's always going to be sort of a ballpark. Yeah. The last.
Please bear with me as I get the PowerPoint back up and running.
So yeah, I mean, so that's the overview of TrapSim Plus. I mean, it was a great opportunity for our team, the wildlife ecology team, to work with others from outside their own areas of expertise, to collaborate together on something that neither group, us or the digital solutions team, would be able to achieve in isolation.
Yeah, and I'd just like to add on to that. It was a great opportunity for our team because I don't think we've often worked with the WEM team, or perhaps not at all. I'm not 100% sure. So that was really lovely. And also it was a really good opportunity for us to bring on some interns, some student interns. And it was a very good project for them because they were able to see the software development process from the very beginning all the way through, almost all the way through to the end. So it was really rewarding for us to be able to give them that opportunity as well.
So yeah, thank you. So it's online now. There's a link at the top there, trapsimplus.landcareresearch.co.nz. It's free, easy to use. There's a support email address there, which comes through to me and the team. So we're really keen for people to use it and try and break it and see where it works and where it doesn't work. And I mean, there's lots of features that we would love to add more realism, but that comes at computational cost, and there's some things we just don't know the values for yet. So this is, as we said, it's a ready reckoner of sorts to help guide people and put you in the ballpark for the level of trapping that you may want to be able to carry out. So yeah, happy to take any questions. There's a lot of acknowledgements there, some people from within the team, some externals that helped fund earlier TrapSim development, as well as the co-leads from the SO5 team and the team members from the software digital solutions team. So thank you on behalf of both of us.
Thanks, Maddie and Andrew. It's a really interesting talk. We've got quite a few questions to get through, so we'll see how we go. To start with, are there any plans to add more species to the list, such as feral cats?
Yeah, so yeah, absolutely. So because this was a National Science Challenge by Heritage project and it was kind of aligned to predator-free, it was kind of limited at this stage to those 6 species. But the only thing holding us back to adding more species is just knowledge about their home range parameters, which we know for feral cats in some areas and for hedgehogs and others. So it's the product itself, the TrapSim Plus, the work that Maddie and her team have done make it really easy to add another species. It's just some input tables that we would have to in the wildlife ecology team to put in and add those through. So short answer is yes. When, I'm not too sure. Yeah.
And what's the land cover layer being used?
Question.
Yeah, so I can't remember what it's called, but there's a land cover layer. I think it's just topographic that we maintain here at Manaki Whenua, but we also have a satellite layer that's provided from LINS. So these are very up to, and our topographic layer is it uses LINS data as well. So these are relatively up to date, about as up to date as they could be for New Zealand.
Well, it's probably the LCDB, I'd imagine. For the land
it's a variant of that. It might not
Yeah.
quite be exactly LCDB, but it's
Cool.
aligned to it.
Can TrapSim be integrated with TrapNZ?
Yeah, that's a really good question. So TrapNZ, where you can feed in your trap data, I mean, it'd be really nice to have that that instead of setting up the scenarios, you could actually read in a trap out, in a trap layout or specifications. So at the moment, no, we can't, but that would be something I'd love to explore for sure. Yeah.
And what if you don't know what trap to use and how many, or do the landowners have to research that separately?
Well, I guess that's the point of the tool, is that if you're really starting from a position of, I just don't know, I've got an area that I want to trap, how many do I put out? Then you try it with 10 or 20 or 50 and see what population reduction you get. And if that's getting you to close to where you want to be, then that gives you some information that that's the number you need to use. If you've only got 50 in your store and that's all you've got, and it's not going to reduce the population by more than 20, 30, 40%, then that tells you something about potentially having to go out and get some more money to buy more traps. So, I mean, yeah, so that's the purpose of the tool, is to guide the users and the managers into how many traps to actually deploy. So this is, I mean, it's a simulation. It's not necessarily reality. So you'd still have to actually go out and apply the network that you think is best, and then monitor those devices and see what you get, and also see whether it matches up with what the tool predicts.
And could bait stations be incorporated into the tool?
So bait stations are in there. They are one of the options, and probably not all the types of devices at the moment. We need to do it. I need to do a little bit of refining around that, but it's ground control in terms of traps and bait stations, yes.
And are seasons considered for the estimations of pest populations in an area?
No, they're not. I mean, that's probably the next thing on the list in terms of that seasonality. I mean, even the immigration parameter is a value that the user would specify, and as in terms of the number of incursions they might expect to get within a month. But of course, that's going to be seasonal as well. So that's one of the parts that's we don't have that realism in there at the moment, and it's a nice to have, but it's certainly on the list of things.
Yeah, definitely. I think it's on our backlog to look into if we have the opportunity to. Yeah.
Yep. There's a very big wish list of additional features. So yeah.
And the device cost, is that the cost to install the device or the material cost to service it each time?
Yeah. good question. So the device cost is the approximate purchase cost. It also includes the labour cost in terms of, so when you input in how many days between servicing it, it will include the cost for setting it up, for removing it at the end, and all those ones in between. And I guess those are the kind of the approximate cost of servicing, but not those consumables, I suppose, in terms of baits and CO2 canisters and things. So you could probably build that into the daily rate. Yeah.
Yeah.
Like I said, it's not it's an approximate costing method. Yeah, you'd have to tweak the actual device costs or something. We probably need to think about making that a bit more realistic. Yeah.
Yeah, and also you can, like, if you're like, oh, I know that this costs more or less than what's on here, then you can also tweak the price yourself. So it's all tweakable, or almost everything that we could add in is tweakable.
Yeah, and even the purchase costs are hard to find, right? Like in terms of, you can have the same trap that's available from two different suppliers, and they vary slightly. So we've kind of come up with a rough average, but yeah. So please don't take this as, when you go and purchase your traps, to say, well, TrapSim Plus said it was $19.95 and you guys are selling it for $30. So what's going on there? It's always going to be a bit variable.
Can you upload data, including actual capture rates from existing operations, to test or improve efficiency? And if so, would it be possible now or as a future development to bulk upload from a source like TrapNZ?
Yeah, that's a great question. So we've thought a lot in the early days of TrapSim as well around, it's a model. So actually testing it with data and model validation is something we really want to explore. Simon Howard and our team did some preliminary work with Hawke's Bay around that. Or was it Taranaki? I can't remember which. Might be Taranaki. About testing our models with real data. So yeah, absolutely. There's no firm plan at the moment, but we need to think of something pretty soon, because ideally we would love people to be able to use a tool like this and make those predictions, but then actually go out and do the work and collect that data. And trap.nz is a perfect repository for that data. So to be able to bring those two together and see where if the model predicts that you would get to some low level, but reality doesn't support that, figure out which of the refinements that need to be made to make the planning tool a bit more realistic. Yeah.
And does the program provide any information on best practice for trap density, etc., or is that a separate process that would need to be decided before inputting the information into TrapSim Plus?
Yeah, I guess that's related to an earlier question that in some ways that is one of the main use cases for the program, is for the user to get that best practice. So for their specific area of a certain size, to explore those scenarios and come up with trap density and number of traps is going to be suitable to achieve their outcomes. I guess we could look at providing some starting points for that in terms of trap densities, but a lot of it will depend on the goal. So if it's for an initial knockdown or low level suppression or eradication, those layouts are going to be, or those required trap densities are going to vary, probably by orders of magnitude. Yeah.
And is it possible to input multiple traps in one area at the same time? For example, sort of 10 A2220s, 50 flipping Timmies, etc., in the same area? So you're modelling that mixed trap model.
Yeah, Maddie?
Yeah, absolutely. You can do that. That was a big request early on. So you can do that. So you can, I can't remember how many you can add in, but you can add in quite a lot of them. And yeah, multiple. I think we've got examples where you can add in like more than 5 different types of things if you're really excited to do that.
Yep.
So yeah, you absolutely can.
Yeah. I mean, that was definitely a requirement from user testing, because people already own traps, right? And so they might have a mix of, they've got 10 Tim's traps and 20 of these. And so to be able to just include those within the same scenario. Yeah.
Cool. And yeah, what features are you planning on adding, particularly for allowing teams to add in their own data or sort of upload existing CSV or shapefiles where you've already got traps located in an area?
Yeah, so at the moment, I mean, you can certainly upload a shapefile of your area. Uploading a CSV of current trap layouts is not a feature of this iteration of TrapSim Plus. It would be great to do. I totally agree, because you could input what you've currently got and then adjust that to explore different options. Yeah, it's certainly high on my list of what we would like to have in there. So, but nothing immediate, I'm afraid. Yeah, we need to look for some more funding to keep this development going. So yeah, collating all these sort of potential requirements and additional features is something we'll take from this as well, to provide a bit, a hit list for the next things.
Cool. Oh, thanks very much, Andrew and Maddie. I think we'll leave the questions there. So thanks for everyone who's joined us for the 5 mammal talks this week. And I'd just like to thank Tiffany Day, who does an exceptional job in setting all of these up, and wrangling scientists, which, as we all know, can be a little challenging at times. So there's one more talk this afternoon from our weeds team. Other than that, we'll see you next year. Thanks.
Cool. Thank you, Sam.
Thanks, everyone.